Okay, we are here talking about with our student Jordan. You ready to do a little bit of discussion of exponents and roots?
Yeah.
Okay, so let's first talk about things like square roots with exponents, because it's interesting, they're kind of opposites. Let's take a look. So a square root of a number multiplies by itself to get that number. That's a lot of words. Let's look at it with some math. So the square root of 25 is 5 because 5 multiplies by itself to get 25. Does that kind of make sense?
Yep.
It's kind of the definition of a square root. You probably have known that for a long time. Now, let's look at this in just a few other ways, though, because what we're going to get to is something that will hopefully help you to work with roots and exponents. So if we have the square root of 25, that's the same thing as the square root of 5 squared, right?
Right.
And that equals 5. So you can see like the square root and the squared kind of cancel each other out so that there's only the 5 left. Make sense?
Yep.
Okay. And then if we look at another example here, and let's do it with a non-perfect square. So we don't know what the square root of 13 is, but we do know that the square root of 13 times the square root of 13 equals 13, right?
Right.
Okay. And we have something by itself, it's squared, right? So that we could rewrite this portion right here as the square root of 13 squared. Does that make sense?
Yeah.
And we know that it equals 13. So here we have another example where instead of up here we had the square root of something squared, here we have the square root squared. Either way, either order, whether the squared's inside or outside, though, they kind of cancel and you're just left with that same number, the 13, or in this case, the 5. Make sense?
Yeah.
Okay, good. So now let's look at a couple more examples. What do you think this is? The square root of 19 quantity squared.
19.
Good, because those cancel out, just like the examples we were just looking at. Okay, let's look at another example. How about this?
14.
Good, because the square root and the squared kind of cancel each other out. Now let's look at a slightly trickier one, see if we can figure it out. Square root of 7 to the 4th. Well, this you could probably figure it out. Any ideas what it might be?
7.
Okay, it's a good guess. Let's actually write it out, because when you get enough of an exponent, you might want to just go ahead and write what the exponent means. So when something's to the 4th power, it's times itself 4 times, right?
Right.
And so there's the 4 square roots of 7. Now, how about these first two square roots? So what's the square root of 7 times square root of 7?
The square root of 7 squared.
Yep, which is also just 7, right?
Right.
Okay, and then this other one is also just 7, this other pair here, right? So we could rewrite that as 7 times 7, and what would that be?
49.
Good. So we started off with this complicated thing over here, but because we knew how to work with roots and exponents, we got to this very simple thing. Let's do one more that's even trickier. Now here we don't have it squared. It's the square root of 5 to the 3rd. So what if we use the same strategy we just used for that 7? What would you first write at?
You would write the square root of 5 3 times.
Good. Okay, now what can we simplify here?
You can simplify the first 2 to 5.
Good. And then we're just left with 5 times the square root of 5. Make sense?
Yeah.
Yeah. And this is, this isn't super simplified. It might not seem, but it's much more simple to write than this. So, and pretty soon you'll get used to working with square roots. So this is actually much simpler. Okay. Now, let's do a quick review of negative exponents so that we can work with some of this same stuff with negative exponents. So we won't explain why, but let's just remind ourselves of a rule. Negative exponents shift something from the numerator to the denominator, or the other direction, from the denominator to the numerator. So for instance, 3 to the negative 2 is the same as 1 over 3 to the 2nd power. Do you remember this rule?
Yeah.
Okay. And then similarly, if we have 1 over a to the negative 5, that's just a to the 5 over 1, or just a to the 5. Okay? Good. Good review. So now let's do some of the same work we did on the left-hand side over here with some negative exponents. So what would this end up equaling? Any ideas?
I'm not sure.
Okay. So if we first just apply the negative exponent, and just kind of like we did up here with 3 to the negative 2, how would you rewrite this right here?
1 over the square root of 5 to the 3rd.
Good. Okay, now that's maybe a little bit easier, because if you look at this, and you look at this example we did over here, what do you see?
It's the same.
It's
So
the same. So we could write it out like that. And then what would we simplify that to?
5 times the square root of 5.
And what would the whole answer be?
1 over 5 times the square root of 5.
Exactly. Okay, so you can work with square roots and exponents even if the exponents are negative, right?
Right.
Great job.